Okay, so here we're looking at Pascal's triangle and its link to combinations. So a quick reminder then on how we look at Pascal's triangle, and the number beneath is found by adding the two numbers above it. Okay, and depending on our application, depending on our intention, will depend on how high up we start. It sometimes starts with a 1, next row we get 1, 1, and then we get 1, 2, 1, and what we should find is that as we go down, our leading diagonals should have a 1, and my two numbers above it, 1 plus 2 are going to give me 3, 2 plus 1 is 3, and then I finish just with a 1. The next row starts with a 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 is 6. So we should find as we're going that it becomes symmetrical as well. So filling in then the fifth row, 4 is 5, and 6 is 10, 6 and 4 is 10, 4 is 5 is 1. And then finally we'll just go down to the sixth row and we'll stop there. 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 6. And 1. Okay, so that then is what we were thinking about when we were thinking about Pascal's triangle. So how does that link in? Well, thinking back to our combinations and what we did. Okay, remembering that our NCR or NR, okay, as we can remember, they can be written. Well, these can be used to calculate the rth entry on the nth row of Pascal's triangle. Okay, I always treat Pascal's triangle like it's a proper noun, but I don't actually know that it is or not, so I'm sure someone will be very quick to tell me otherwise. However, what does that actually mean for us? Well, let's say we wanted to write down the 8th row of Pascal's triangle. Give it a small t there, let's keep everybody happy. So what we would be looking for then is we have got, in terms of our combinations, we would have 8C0, 8C1, 8C2, 8C3, 8C4, 8C5, 8C6, 8C7, and 8C8. And what we're doing is we're thinking about what those numbers are in the 8th row of Pascal's triangle. And if we were to extend it as far as the 8th row, we should find that there were 7 things, and those 7 things should be the exact same numbers. So if we think about, we've got a pool of 8 objects and we want to choose none of them, how many ways are there of doing it? Well, there's one way, you pick none of them. If you've got 8 things and you want to pick one thing from each, how many ways are there? There are 8 ways of doing that. Okay, just one way for each thing, and so on. And so we actually find that if we were to work them out, or use our calculator to help us get them, we have 28, 56, 70, 56, 28, 8, and 1. And if we extend the triangle from above, our next 2 rows, we should find that the row that we end up matches that line exactly. So, how can we use this to help us? So, what we might want to do, thinking back to the previous videos, we might want to expand 2x minus 3y to the power 6. And so that is going to be 6c0 lots of 2x to the power 6 plus 6c1 2x to the power 5 minus 3y plus 6c2 2x to the 4 is minus 3y plus 6c3 2x cubed minus 3y cubed, and I've messed out my squared from that term there, plus 6c4 2x and minus 3y to the 4, again I've missed my square from that one, plus 6c5 lots of 2x and minus 3y to the power 5 plus 6c6 minus 3y to the 6. And if we churn that out, if we ask our calculator to give us some of these answers, get this freehand, we should find that we end up getting 64x to the 6 minus 576 x to the 5y plus 2160x to the 4y squared. But it's not going to be plus, it's going to be minus next. We should find that it should alternate. If we've got 1 plus and 1 minus, each of our terms should go plus, minus, and so it should be minus 4, 3, 2, 0, x cubed, y cubed, plus 4, 8, 6, 0, x squared, y to the 4. Let's come down this side, so we've got minus 2916 x y to the 5th plus 729 y to the 6. Okay, and so yes, in general, thinking about what it is we've got, if we've got x plus y to the nth power, then that is equal to n choose 0 x to the n plus n choose 1 x to the n minus 1 y plus n choose 2 x to the n minus 2 y squared, and so on. Or we want to think about it in a more general way. We've got x plus y to the n is equal to the sum from r equals 0 up to n of n, choose r, x to the n minus r, y to the r. Okay, and this formula here is our binomial theorem.